Hey guys, how's it going? So today we are going to look at section 1.8, and this one deals a lot with ratios and proportions. So I guess it's kind of switching up the gears a little bit from the past sections that we've been doing, but we're going to incorporate a lot of the same stuff later on in the more challenging problems. So in order to get an idea of ratios and proportions, let's go ahead and see if we can figure out some ways that we have represented them in the past. So you guys might have seen ratios in this form. So you might have seen something like, I don't know, 3 to 5 using a colon, okay? Or you might have seen something like this, 3 over 5 or 3 divided by 5, but another way of saying it is 3 to 5. Or you might have actually seen it in writing, something like that, 3 to 5, all right? So let's go ahead and do some ratios like if we were in class right now. So I believe right now in our class we have 10 boys and 9 girls. So our ratios of boys to girls is, again, 10 boys to 9 girls. All right. If we were to do blue eyes to brown eyes, let's say, I don't know, 12 people have blue eyes and only 7 people have brown eyes. Okay. All right. So again, we just have to make sure we represent this in the correct order. So if there's 10 boys, then you have to write 10 first. If you have 10 girls, I'm sorry, 9 girls, then you have to write the 9 second. Okay? You always have to go in the sequence that it's written. It's written in words, boys to girls, so it has to be 10 to 9. Okay? All right. So let's go ahead and talk about what a proportion is. So all a proportion is comparing. It compares to, whoops, excuse me. It compares to equal ratios. Okay, so all we're doing is comparing two equal ratios. All right. So what does that look like? So I'm going to give you guys a quick example here on the right hand side. So if we have 1/2 equals 2/4, well, we know that 2/4, if you were to reduce it, it would just turn into 1/2. So 1/2, let me highlight that real quick. So 1/2 is equal to 2/4. Okay, so those two are equal to each other, hence they are a proportion. So let's go ahead and look at a few examples of proportions and how we can solve them. All right. So it says directions. Solve the following proportions. All right, now in order to do that, we're going to make use of, and if you want to write it up here, you're going to make use of cross multiplication. So write that off to the side so you can remember whenever you're doing proportions, okay? Whenever you're doing proportions, you're doing cross multiplication. Okay, so that's what we're going to do here, guys. We're going to go ahead and cross multiply the 2 and the x and then the 4 and the 10 because we have a proportion. We're trying to figure out what that x value could possibly be. So you're going to go ahead and set that up. So I have 4 times, remember, we're multiplying here, cross multiplication, and then 2 times x. Now I'm using parentheses to signify multiplication. If you want, you could use the dot. Okay, that's totally fine. The reason why I'm focusing on using the parentheses is because later on we have to make sure we always use parentheses because we might need to distribute. Okay, so let's see, what do we get? 4 times 10, well, that's just 40. 2 times x, 2x. Well, what do we do now? Well, this just becomes a problem we've solved before. We divide by 2, we get 20 equals x as our final answer. Okay, so nothing to it, pretty simple. We just have to make sure we follow the correct steps. Okay, now this next one you might be wondering, well, what about that negative? Should I leave it at the top or put it in the bottom with the 5, or what should I do? Well, actually, it doesn't matter, to be honest. So I'm going to actually go ahead and keep it with the negative 6, or with the 6, I'm sorry. And then I'm going to actually multiply those two, okay? So let's go ahead and multiply that out. So what's negative 6 times 15? So I'm going to actually rewrite them first. And then I have a 5 times an x. So negative 6 times 15, that's a negative 90. 5 times x is just a 5x. All right, next one. Or I'm sorry, not the next one. We just have to finish this off. We have to divide by 5. What do we get? We get x equals negative 90 divided by 5 is just a negative 18. So we have our answer. X equals negative 18. Now again, with these two problems, guys, before we move on to the third one, I want to prove to you guys that it in fact is true, what we just did. So I'm actually going to make a small section here, and you don't have to do this. If you want to, you absolutely can, but I'm actually going to leave a little section here where I'm going to test that out. I'm going to make sure that if I do substitute in 20 for x, I will get something that is proportional, or rather equal. Okay, so let's try that out. So this is, let's go ahead and do 4 over, again, now my 20 goes in here for x, and 2 over 10. So, well, let me just concentrate on this first part, 4 divided by 20. Well, those two have a 4 in common. So if I divide each of them by 4, what do I get? I get 1 over 20 divided by 4 is just 5. Okay, now what about here? What do the 2 and the 10 have in common? Well, they have a 2 in common. So if I divide them both by 2, what do I get? I also get 2 divided by 2, which is 1, 10 divided by 2, which is 5. Now, are these two the same? Yep, they are equal to each other, so in fact we did have a proportion. We did have two equal ratios. Okay, and again, you can try that for number 2 right off to the side if you want to, but let's actually go ahead and move on to number 3. So, excuse me. So once again, we're going to cross multiply. So I'm going to go ahead and multiply the 6 with the 4w and the 7 with the 9. Now remember, guys, how you set this up when you cross multiply is very important. A lot of you guys might try to do this, 7 times 9, and won't know what to put here. It's always an equal to sign, guys. A lot of people might try to put a multiplication symbol there, or just completely forget to put something there. So remember, you're trying to compare something that's equal. So when you cross multiply, you have to set it equal to the next multiplication, which in this case would be 6 times 4w. Again, try to get in the habit of using parentheses to demonstrate multiplication, guys, because we will need to do that whenever we have a term that's a binomial or a trinomial in one of these fractions. Okay, so 7 times 9, that's just a 63. 6 times 4 is a 24w. Now, if I go ahead and divide out 24, I get, all right? See, these cancel out, so I get w equals 63 over 24, but I believe I can reduce that a little more. So off to the side here, I'm going to write w equals, let's see, what do those two have in common? I think they have a 3 in common, so if I divide them both by 3, we get w equals 21 over 8. And remember, well, excuse me, remember, guys, you guys can always type that into your calculator. 63 divided by 24. If you have one of those graphing calculators, remember you can always do math, enter, enter. to get this fraction of 21 over 8. Or if we were doing if we were doing decimals, we would get 2.6 when we divide that out. So both of those answers are acceptable because we did not specify in what form we wanted it in. Okay, I'm going to do one more with you guys, and then I'm going to have you guys try out 5 and 6 on your own. So let's go ahead and take a look at it. So we have 8 times 9 equal to m times 3, or 3 times m. Okay, so I'm going to have 8 times 9 equals m times 3. Okay, and it doesn't matter what order, guys. All that matters is that you're multiplying diagonally. Okay, the 8 with the 9 and the m with the 3. Okay, so what do we get? 8 times 9, that's 72. M times 3 is just a 3m. I get the m by itself, so I'm going to divide by 3. And I get m equals 24. All right. So again, if you wanted to double check that, you can always make sure you can plug that back in and make sure that you did get the correct answer. Okay. So I'm going to have you guys try out 5 and 6 on your own, and we'll come back and double check our answers. So go ahead and pause the video. Okay, let's go ahead and solve this next one. So I'm going to actually do 2p times negative 5. So I'm going to keep that negative with the 5. And then I'm going to do 6 times 8. Now remember, guys, if you already put the negative with the 5, you don't have to put another negative with the 8. It's only one negative. Okay, so let's actually write this out. So we have 6 times 8 and 2p times negative 5. All right, let's multiply that out. We get 48 equals negative 10p. We need to get the p by itself. So I'm going to divide those two. I get p equals, let's see, 48 divided by negative 10. Well, if I reduce that, I believe they have a 2 in common, so I should get 24 over 5. And remember, it's a negative 24 over 5. All right, so that is my final answer. Or if you have this in decimal form, you might have, let's see, negative 4.8 as your answer. Okay, so both of those answers are acceptable. All right, let's take a look at this final one. So we have 5 times 2, so 5 times 2 equals 3 times 8h. This is just 10 equals 24h. Once again, divide by the 24. We get 10 divided by 24, which reduces because I believe they both have a 2 in common. So this would be a 5 over 12. Or once again, if you are solving by plugging it into your calculator and just getting a decimal, you should get 0.417. Okay, so I hope you guys are doing well so far. I hope you guys got the same answers as I did. And now we are going to be actually moving on to something a little harder. Okay, and this is the reason why I said try to get used to multiplying using parentheses, because here it's vital that we do that. So let's continue on. Again, we have a proportion because we have two fractions or two ratios that are equal to each other. So I'm going to set this up. I'm going to do 9 times t equals 5 times, well, again, I have a 7 plus 4. I'm sorry, a t plus 4. I don't know what I was thinking there. All right, so 9 times t, that's just a 9t. Now, be careful here. I see a parentheses that has two terms inside of it, so I have to distribute the 5. So I get 5t plus 20. All right, so let's go ahead and solve the rest of this. Now, I have to double check to see if I can combine any like terms after distributing. But it doesn't look like I can combine anything, but I do have variables on both sides. So I have to move the smaller variable over. So I get 9t minus 5t, which is 4t. Those two canceled out, and I get a 20 on this side. Now, finally, to get the t by itself, divide by 4. I get t equals okay, hopefully you guys got t equals 5. All right, and again, if you want to double check your answer, you can always substitute that back into your original proportion. Okay, good. So let's go ahead and take a quick look at number 8, and then I'm going to have you guys try out a few on your own. So number 8 says y plus 4 times 5, and I'm actually going to write the 5 first so I can distribute the y plus 4, and then I'm going to have 3 times y. Okay, so I'm going to distribute my 5 to both of those terms, so 5y plus 20 equals 3y. Can't combine any like terms, however, I do have variables on both sides. Now again, just like before, if I move the smaller one here, I'm going to get rid of everything on the right hand side, and I don't really want that. I want a constant on one side and I want variable on the other side. So what I'm actually going to do is get rid of the 5y. This way I'm left with 20 on the left side, so the constant on the left side and variable term on the right side. Okay, so that worked out kind of nice. Now I just have to divide by -2. So I get y equals -10. Okay, I hope you guys got a similar answer here. Again, double check your answers, guys, if you are not sure, especially on tests or quizzes. If you have enough time to do so, plug those numbers back in to verify that the equation or that the proportion is still true. That way you will have a good guarantee that you have your answers correct. All right, so I'm going to try out one of these with you guys because this time we have binomials on both the tops of both of those ratios. So I'm going to go ahead and do one with you guys, and then you guys are going to try that last one on your own. So I'm going to do 4 times x plus 8, and again, because we like to distribute a number, I'm going to actually use the 4 in the front and then put the x plus 8 in the parentheses. And then I have x minus 5 times 2. Again, I'm going to put the 2 first and then the x minus 5. Now I can distribute. So I get 4x plus 32 equals 2x minus 10. Can I combine like terms? No, I can't. However, I do have variables on both sides, so I'm going to move the smaller one. So I get 2x plus 32 equals -10. All right, and I'm actually going to move this over here since I need a little bit more room. Okay, so next thing, I got to get rid of my 32 first, and then I'm going to get rid of that 2 in front of the x. So what do I get? I get 2x equals -42. Finally, divide by the 2. I get x equals -21. Okay. All right. So, up to you guys to do number 10 on your own, so go ahead and pause the video and give that a shot. Alright guys, let's go ahead and try this problem out. So, I'm going to cross multiply these first, so 10 parentheses x minus 2. And then I'm going to cross multiply the 4. So 4x plus 10. Awesome. So let's keep going. So I'm going to distribute both of these terms. So I get 10x minus 20 equals 4x plus 40. Can't combine anything, but I can move the smaller variable. So I get, I get 6x minus 20 equals 40. Use SADMAP to get the 20 on the other side. So I get 6x equals 60 divided by 6 for a final answer of x equals 10. So hopefully you guys got 10 when you tried this problem on your own. Alright, so it looks like that was it for this section, guys, but I want to get a little bit of a review in from the past sections that we've been doing, just to make sure we keep up to date with everything that we've done. Okay, so let's go ahead and continue on with this review problems, and then we will be done for the lesson. So let's go ahead and see what we got. So it says, for 11 through 15, solve the following equations if possible. Okay, so let's see. So right off the bat on number 11, I can see that those two are like terms. Okay, so go ahead and combine those two terms. So what I get, 7.2r minus 5.4r is a 1.8r. And on the right hand side, I have the negative 11.7. I can now use SADMAP because I have only one variable, so I don't have to get the two variables that were on both sides on just one. So I'm using SADMAP here, so I get r equals, let's see, what is that, negative 6.5, if I'm not mistaken. So we have our final answer. Okay, so all we did was combine like terms. Because we didn't have variables on both sides, we can go straight to SADMAP. So I divided by the 1.8 and got our answer. So let's go ahead and do this next one. Distribute that 3 halves. So it's 3 halves d minus 3 halves times 10. Well, that is just, let's see, let's go ahead and actually write it down. 3 halves times 10 equals 6. Now, the reason why I wrote it down is because you guys, if you want to, you can go ahead and multiply that negative 3 halves times 10 on your calculator. But if you don't have a calculator, remember, you can always reduce here, guys. These two, remember, this is like 10 over 1. Excuse me. And you're multiplying here, so you can reduce these. This 2 goes into 2 once, but the 2 also goes into 10 5 times. So this actually is 3 halves d minus, well, let's multiply the numerators. 3 times 5 is 15. And in the denominators, I just get 1, so that's really just minus 15. I could write minus 15 over 1, but that would just be overkill, and we honestly don't need that. Okay? Now that we have that, let's see, we only have a variable on one side, so we can go straight to SADMAP. So I'm going to get rid of that 15. So I'm going to go ahead and do 3 halves d equals 21. All right. So in the past, we've tackled this type of problem in two different ways. We've tried doing SADMAP by going ahead and getting rid of that division by 2 by multiplying 2 on both sides and then dividing by the 3 to get the d by itself. However, I think you guys are getting to the point where you need to start learning some shorter methods. So what I'm actually going to do is multiply by the reciprocal. Remember, guys, we don't like dividing fractions because I could have easily divided this whole thing by 3 halves. We don't like dividing fractions. Rather, we'd like to multiply them instead. because this way, now my 3 and my 3 go away, and my 2 and my 2 go away. So I really just have D equals, same thing here, that 21 I could put it over 1. What does 21 and 3 have in common? Well, they have a 3, so 21 divided by 3 is 7, 3 divided by 3 is 1. So I just get 7 times 2, which is 14. Okay? So I get D equals 14. All right. Cool. Keep going. Next one. Negative 7a plus 4 parentheses a plus 6 equals 34 minus 5a. Well, right away I can tell you that we should probably multiply, or I'm sorry, we should probably distribute. I hope you guys spotted that as well. So let's go ahead and do that. Negative 7a plus 4a plus 24 equals 34 minus 5a. Now it's up to us to find something I can combine, if there is anything I can combine. But right away I see those two. I could definitely combine some like terms there. And it doesn't look like there's anything else I can combine, so let's go ahead and combine just those. So I get negative 3a plus 24 equals 34 minus 5a. Okay, I have variables on both sides. I'm going to move to the smallest one. The smaller one is the negative 5a, so I'm going to add 5a. So what do I get? I get 2a plus 24 equals 34. Finally, I have variable just on one side, so I can move on to SADMAP, get rid of the 24. So I get 2a equals a positive 10. Divide both sides by 2 to get the a by itself. So I get a equals 5. Awesome. Good. So far these have all had good solutions. So we haven't had to worry about any of those special cases we've done in the past. So let's go ahead and keep going. Now, number 14, we have actually two sets of parentheses, so we're going to have to distribute twice. So I'm going to go ahead and distribute that negative 5 as well as that negative 7. So I get negative 5k plus 5. Remember, negative times a negative is a positive. So this is also just a 7k minus 49 plus 6k. Okay. Can I combine anything? Yep. I can combine those. So I get negative 5k plus 5 equals 13k minus 49. All right, can't combine anything else, but now I can move my smaller variable. So I add 5k to both sides. Get 5 equals 18k minus 49. We can move on to adding the 49 on both sides. So what do we get? 49 plus 5 is a positive 54 equals 18k. Last step, divide by 18. Get k equals 3. All right. Awesome. Let's go ahead and take a look at our last problem. And actually, I'm going to go ahead and pause. I'm going to have you guys pause the video right now because I want to see if you guys can try this one on your own. It's probably the most challenging out of the set because there's one thing you have to remember. Okay? Something we've done in actually the previous section. But go ahead and pause the video right now and try this one out on your own. All right, guys. Let's see if you guys got it. Okay? So right away I see a parentheses, and I always like to take care of those first. Okay, I like to distribute and make sure I have multiplied out before I combine like terms. So I'm going to do that. So on this left side we haven't done anything, and on this right side I get negative 4x minus 4 minus x. Now, a lot of you guys might have combined the 9x minus 14x first. That's totally fine. This is just my way of making sure I'm following my steps by making sure I do distribution first. But if you combine those first terms on the left side, that's totally fine because I'm actually about to do that now. I could definitely combine those two, all right? And on the right-hand side, I can combine those two. So let's see what I get. I get negative 4 minus 5x. Then I get negative 4x, negative 4, and then negative 4x minus x is a negative 5x. Now, a lot of you guys may have stopped there, okay? Because, and that's where I'm going to stop, because I see right away that this is the exact same thing as this. So there's no reason to go any further. I can tell right away that no matter what number x is, I'm always going to get the exact same thing because already both sides are equal to each other. So that means I have infinitely many solutions. Okay, I have infinitely many solutions. If you did not stop there, you might have gone a little bit further. So let's go ahead and look at that. I'm sure you probably added 5x to both sides. You get negative 4 equals negative 4. Is that a true statement? Yes, it is true. And because it is true, then again, you get infinitely many solutions. All right, so that was just a quick recap of stuff we did in the last section, plus a little bit more of what we did in the previous sections before that on chapter 1. All right, guys, well, I hope this helped for you guys to get a better idea on how to do proportions from this top part, okay? Make sure that you rewatch the video if something did not make sense, or you ask your teacher as well as myself on if you had any sort of questions that you'd like to get addressed. All right, guys, have a good one.